I'm Anil Kumar sharing with you practice questions on annuities. Question here is, Peter wants to make monthly deposit into an account that guarantees 9.6% per annum compounded monthly. He would like to have 100,000 in the account at the end of 10 years. How much should he deposit each month? Right, so that is what the question is. Now, this is a case of simple annuity where regular payments are being made at a regular interval and the payments coincides with the compounding period, right? So that is a simple ordinary annuity. Now, when we say Peter wants to make monthly deposits into an account that guarantees 9.6% per annum compounded monthly, that means the interest rate is 9.6% means divided by 100, 9.6%. Compounded monthly means you have to divide it by 12. Do you see that? Every month interest will be 1/12 of that. So that is the value of I, the interest. So let's calculate this. So it is 9.6 divided by 1200, which is in decimals 0.008, right? So it gives you 10 to the power of minus 3. It gives you, let me write down, 10 to the power of minus 3. Right, so that means basically 0.008, right? So because 1, 2, and 3. So from here, you're going to move decimal 3 places to the left. So from here, 1, 2, and 3, correct? So I hope that helps because I've seen some students getting confused on this also. So 9.6%, you could have written 0.096 divided by 12 also. You'll get the same result. So the interest rate effectively is 0.008 per compounding period, right? So our compounding period in this particular case is monthly, right? Now, he would like to have that much amount. So that is the future value. In future, he wants $100,000. So that is the future value. Okay, in the account at the end of 10 years. So 10 years is the total time, and how many compounding periods are there? Let me write compounding periods. In 10 years, we are doing every month, so times 12. So compounding periods is 120. This is the value of n in our formula, right? So now let's write down the formula, which is future value is equals to r times 1 plus I to the power of n minus 1 divided by I, right? So that is the formula. Now in this formula you will see we know future value, which is 100,000. So let's substitute. So it is 100,000 equals to R, we want to calculate. So we need to really find what R is. Peter wants to make monthly deposits and we don't know how much. So how much should he deposit each month? That is what we need to calculate, R value. Okay, so R, and here we know I, which is 1 plus I is 0.008 to the power of n. N is 120 for us, minus 1 divided by I, which is 0.008. Now it is a question of rearranging this formula and finding the answer, right? So what we can do is we can multiply this 100,000 by 0.008 and then we'll divide by this number, correct? So that is how we can find R as. So R will be equals to, we'll multiply 100,000 times 0.008 and then we'll divide all this by all this, which is, I can write this as, let me put the brackets, 1.008, right? 1.008 to the power of 120, right? Minus 1. Is it okay? So you could do this and find the value of R. That is how you have to rearrange and do it. So that is one way of doing it. So let's do it. So what I will do here is kind of do it in two steps. So we have 100, 1, 2, 3 times 0.008, which is equals to 800, right? So let me write down this. So let's take it to this side, okay. So it is 800 divided by, now this term in the denominator is 1.008 to the power of 120 equals to minus 1, right? Equals to a big number, which is 1.601739 something, right? I will not like you to round this number. I'm just showing you how to do it, but that is not the right way anyway. So that is your answer. You actually do it in one shot, right? That is always better. So let me show you now how to do it in one way using brackets. So it is, and then find the answer directly. So it is 100, 1, 2, 3,000 times 0.008 equals to, divided by, put brackets. So two brackets. 1.008 to the power of 120 minus 1, bracket close, equals to, well, two brackets close. So you get 499.456. So we'll round it to two decimal places, right? Always in cents. So we get 499.46 as our regular deposits. Now look at this calculation once again. If suppose you round this number in the denominator, do the way I was trying to do earlier, then what do you get? So I want to show you that also. So what you have here is 800 divided by, let us say we round this number to 1.6017. And if I divide by 1.6017, right, and then calculate, I get 499.46. This is very close, it's okay. So at times you may round to some 4 or 5 digits and then calculate. But if the numbers are very high, at times it has been seen to cause more errors. In this case, it didn't. Anyway, so our value is, so we can write down answer, as regular deposits are, should be equal to $499.46, right? Rounding to cents is a good idea. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.